In this video, I'm going to take you through some of the problems on the last page of the 3-2D lesson. Feel free to pause or rewind the video at any point. We're going to start with number 17. This first batch of problems ask for equations of lines in slope-intercept form that satisfy the given requirements. The first one, we're going to build an equation that's parallel to the given line, which means that we're going to use a slope of -1/4, passing through the point -6, 3. And we're going to plug all of this into y equals mx plus b to build a new equation. So we've got 3 equals -1/4 times -6 plus b, which comes out to be 3 equals 3/2 plus b. Do our additive inverse, and -1.5 plus 3 is 3/2 or 1.5. And so here's our b, this is our m, and we have a separate line from the original one, which is y equals -1/4 x plus 3/2. And then if we wanted to write it in standard form, which we don't need to do right now, we would just convert this equation into standard form. Number 18, we're going to build an equation that's perpendicular, which means we're going to take the current slope and do the opposite reciprocal. On every problem, they give us one other fact about the line, which in this case is that the point we want it to pass through is 1, -2. So we plug this into slope-intercept form again. And so b is going to be whatever -12 6 plus 1/6 is, which means that b is -11/6. And we take y and x and plug them back in as variables. We plug in m and b. And there is the equation of the line that is perpendicular in slope-intercept form. 19 says we're going to build a perpendicular line to y equals 8. And y equals 8 is a horizontal line. Here's the x-axis and the y-axis. Up at +8. We want to build a new line that's at -4, 5. Perpendicular would be vertical. And all vertical lines are x equals, and so the x value is x equals -4. Remember, technically this line is not in slope-intercept form, so this maybe should say standard form for this problem, but since there isn't another way to write this, we will write it as x equals -4. Number 20, we're going to write an equation that passes through this point and is parallel to this line. So that's a horizontal line, so I know my other line's also going to be horizontal. And if I want it to pass through the point 0, 2, I know that it must have a height of 2, a y-intercept of 2. The y value for this line is 2, so all ordered pairs with a y value of 2. So there's generally not work for these horizontal vertical ones. You can do a sketch if that's helpful, or you can just think through it and get your answer. The last part of this, we're going to kind of repeat the same things, but this time we're going to write them in standard form. So when we're done with our slope-intercept, then we will move x and y to the same side, the constant to the other side, and clear out any fractions. We'll also make sure that the coefficient of x is positive. Perpendicular to this line, so the current slope for this line is 1, so perpendicular would be -1. We're going to use this point. Just so happens to be the x-intercept. Doesn't really matter. And we get that b equals -3. Then we'll plug this in to our slope-intercept form, which is y equals -x minus 3. We'll add x to both sides. And we get our standard form. This abides by all the rules of standard form, which is x plus y equals -3. 22, we're going to write the equation that's parallel to this. So first thing I'm going to do is take my given line and spend a little bit of time rewriting this into slope-intercept form so I know what the slope is. And now that I have this in slope-intercept form, I'm going to take the slope, and for my new line, I'm going to keep it the same. I'm going to take my point, which is 1, 8, and I'm going to plug this into slope-intercept form and solve for b. And then I'm going to take my equation, which is y equals 1/2 x plus 15 halves. And I'm now going to convert this into standard, subtract my x term from both sides. And multiply by -2 to clear out my fractions and to make sure that the x term is positive. I get x minus 2y equals -15, which is my standard form. 23. States we're going to write the equation that's parallel to this one. Parallel is going to be also a y equals, and my y value for this is 3. So it must be y equals 3. All ordered pairs with a y value of 3. Number 24, I can already spot this one's going to be like 23, but I'm going to do this extra step just to be safe. But I notice that it doesn't have an x term, so this is also a horizontal line, but I want it to be perpendicular, so it's going to be vertical, which is x equals, and my x value is 10. Again, not a bad idea to sketch these if this little amount of work is not enough. In the last one, we're going to write the equation of a line that's parallel to the given one. So we'll start with getting this into slope-intercept form. So I know if I want it parallel, that my slope is going to be -1. I want it to have this y-intercept, so let's find this y-intercept. I have a couple ways to find intercepts. I'm just going to write it in slope-intercept form. I could also plug in 0 for x. All right, so that means I now know that my b value for this line is -1/2. And I'm going to put this all together for my third line, my new line, which is y equals -x minus 1/2. And I'm going to clear it with a 2. And it's okay if the constant or the c is negative. So in this video, I reviewed some of the more challenging parallel perpendicular ones, which also involved writing them in standard form as well as slope-intercept form.